Hello everyone and welcome back. So now we're going to be learning about something called specific gravity. Specific gravity. It sounds fancy because it's awesome. Okay, I'll make myself just a little bit smaller so I can fit in this corner. There we go. Okay, so still, specific gravity. Now specific gravity is a ratio. It's a ratio of the densities or specific weights of some substance divided by the density or specific weight of water. Now, why can't it be density or specific weight? Because specific weight is simply density times gravity. So if it's a ratio, gravity cancels out. So it's usually defined like this. We use a capital S and G. That's not some fancy Greek letter. It's just an S and a G, specific gravity. And it's equal to the density of the object over the density of water. By and large, you will use this to calculate the density of some object. They will give you the specific gravity, and then you will calculate the density of the object using that. It's also absolutely fantastic for density conversions, as we're going to learn next time. Okay, so how does it work? Well, if you want to calculate the specific gravity of something, you simply calculate its density. In this case, I have 4 kilograms in a 2 meter cube box. So 4 divided by 2 is 2 kilograms per meter cubed. And the density of water is not something you calculate, it's something you look up. Do not try to calculate the density of water. It is something you have in your book. You should try to write it down somewhere you can find it in several different unit systems. The most common is 1,000 kilograms per meter cubed. You're like, wow, that's so perfect. It's because the kilogram was actually defined based on water, as was the liter, as was a lot of different things. They're all based on water. So it was meant to be perfect with water, and so it is. Okay, now 1,000 kilograms per meter cubed. That's one that would be good to memorize. You don't have to. It's in your book, but it could be helpful. Now, with that, if you then compare the two, what you see is that the density of our box over here is much, much less than the density of water. It is a tiny fraction of it. So if I divide the two to get the specific gravity, what I see is that it's a specific gravity of 0.002, which is, we're talking about like gases here, and the specific gravity of gas is about this much. So this one right here, our volume on the other side must be a gas. And that's not actually too far off. Air is about 1 kilogram per meter cubed, so this is just twice as dense as air, and it's just a little bit denser gas. So 0.002. The highest you're ever probably going to see for specific gravity is somewhere in the 20s. You might have a little bit higher, but if you get anything higher than that, you're at some new crazy state of matter. Liquids are usually around 1 to 2. Except for mercury, which is weird, it's like 13. So not always the same. It's not super important that you remember exactly what those values are, but you should know a range of what you should see. So some tiny fraction if it's a gas to about 20-ish if it's a solid. That'll help you out. Okay, so I'm going to stop here this time because we're going to go into quite a bit of detail about converting and using specific gravity to convert next time. But please remember that you need to have written down somewhere you can find it all the densities of water. Density of water is the same, it just has different units. Make sure you write it down so that you can reference it, and it will save you so much trouble when it comes to density conversions. Well, I hope this helps you, and I'll see all of you next time. Bye-bye.